Okay, so for number 2, I'm going to go ahead and erase all my, sorry about the shaking. Now listen, as I'm erasing this, I want to tell you, I've gotten some constructive criticism, I'll call it, about how fast I talk. I will attempt to speak slower. However, I talk fast. If I go too fast, if I move too fast through these questions, you have a beautiful thing called the pause button. Click the pause button if I'm going too fast or you can't keep up with my writing, catch up, and then go forward. Or you can even hit the pause button, rewind it, and as annoying as my voice is, you can listen to it again. Listen to it 2 or 3 times until it finally sinks in. Okay, so refer to the graphs illustrated in problem 1. Does graph A, so we're dealing with line A here. Whoa, that was bad. So we're dealing with line A here. Show a proportional linear relationship. Okay, I don't know how many times I've asked you this, guys. A proportional linear relationship goes through the origin. Does that go through the origin? No. So your answer should be no, because it, let's be proper. No, because the line does not go through the origin. Okay. Does the rule C equals 7n model a proportional linear relationship? Now, remember that the word proportional means that it relies, that y, or C in this case, only relies on the rate. It doesn't get affected by the plus or minus. Does this have a plus or minus standing by itself? No. It has no y-intercept, or the y-intercept, by the way, if you wanted to write in, would be a plus 0. It means that goes through the origin, so it is proportional. So, yes, because you can write a couple of things. It does not have the plus or minus number standing by itself, or yes, because it goes through the origin. Either way works for me. Okay, does the XY table shown here represent a proportional relationship? Immediately. Look at that. Look at that right there. 0, 4. If I were to graph that quickly, 0, 1, 2, 3, 4 goes right here. So I don't care if that line looked like that, or that. Proportional linear has to go through the origin. There's no way this line, this straight line, can go through that dot and the origin at the same time, and so no, because it cannot go through the origin and the point 0.04. Again, pause it if you need to. Is the rate of change constant? A lot of you guys got half points for this. You found the first difference of +1, and you found the first difference of +2. You found the first difference of x to be +5, and you found the difference of x to be +10. Then you said no, but here's the key. It is a rate of change, if the rate of change is constant. Remember, rate of change means speed. So think about this in speed. If I went 1 mile in 5 minutes, 1 divided by 5 gives me 0.20 miles per hour. So from here to here, I went 0.2 miles per hour. Remember, it's the change in y divided by the change in x. Now let's do the next change in y over the change in x. The change in y for the second one is 2. The change in x for the second one is 10. So it's like going 2 miles in 10 hours. Well, 2 divided by 10, class, still 2 miles per hour. Did I change my speed? No, my speed remained constant. So if my speed remains constant, I have a constant rate of change. So yes, and I want you to come up with a sentence for, oh no, it's mathematical justification. So mathematical evidence is right here. Okay, cruising along. Number 4. Oh my gosh, if I wasn't shocked at this. Unit rate means how much for 1 unit. How much for 1? If I buy 8 juice boxes for $3.04, does it make sense that if I just buy 1, I'm going to pay over $2, which is what most of you told me. You said $2 per juice box. Wait a minute. If they were $2 a piece and I bought 8, 2, 4, 6, 8, 10, 12, 14. That's $16. I only pay $3. So I want to know how many dollars for one juice box. So dollars per juice box. Dollars goes on the top, 8 juice boxes go on the bottom. Simple as that, divide. You get $0.83, I think it's maybe even repeating, per juice box. I gave you half point even if you just got the units. If you wrote dollars per juice box correctly, I gave you a half point. If you got the 0.83, I gave you the half point. You got both, you got the full point. All right, now which makes sense? Heartbeats per minute or minutes per heartbeat. Think about it. Imagine a conversation you're having with your buddy and you're going, okay, well, I just ran a marathon and my minutes per heartbeat is through the roof. No, that doesn't make sense. Heartbeats per minute makes sense. So 520 heartbeats in 6.5 minutes. 520 divided by 6.5 gives you 80 heartbeats per minute. That makes sense. Okay, that's that one through 4, so go ahead and watch the next one for the rest.